So x plus 4.
So, here is what we're going to do today. We are going to look at this function. What is that called? It's a polynomial function. Remember what a polynomial function is? It's a curvy, smoothie curve, bunch of hills.
Yeah.
Okay, graph. Now, what do I have here? I have a pretend graph. I just drew this. And this is if it was factored completely. Actually, I'm going to change this to the 16 to 25 because that factors. No, I don't want to do 25 either. I want to do
36, 49.
10. I want to do 10.
Oh.
Okay, there's a reason. All right, so can you tell me what all the zeros are? What are all the zeros?
Got 2 so far.
2 of them I know, right? Very easy, right?
True.
2, and what's this one? What?
Not -7.
-1. Sorry.
I can count.
Sorry, guys. -1. So let's say this is 2, and this is my -1. What are these 2 zeros?
Plus and minus x squared and
Very good. Now, how did you get that, Regine?
well, you just do x squared minus 10 equals 0, then you add 10, and then the square root.
What process is this called? Taking the square root of both sides.
I was like solving for x. I was like, what?
Well, it's take the square root of both sides. That's what we call that. All right, so now, how many zeros do you see?
4.
4. These are called real solutions. There are 4 real solutions here. They are real. We're going to say this is minus root 10. We're going to say this one is -1.
Yeah.
This one we'll pretend is 2, and this one
Yeah.
is positive square root of 10.
From 16 to
Now, these are called real solutions, right? Now, within the set of real solutions, we have rational and we have irrational. How would you classify these 4 zeros?
Irrational.
2, -1 goes irrational.
These 2 are rational and these 2 are irrational. But they're all real.
Yeah.
Okay, they're all real answers. Now, what if I would have done this? X squared plus 10. And I said name all rational or real zeros. What would you
Rational
tell me?
or real or
2
rational?
and then
Rational and real. There's going to be
Real.
separate questions.
It's gonna be
What
2.
do you do here?
Well, that's gonna be imaginary, right?
Very good. You're going to get 2 imaginary zeros. How do I know they're imaginary?
Because there's a negative. So I'm gonna take
You're going to take the square root of a -10, and you can't do that, so these are imaginary. These 2 zeros are not real. These are imaginary. But these 2 are rational, and they are real. Rational is real. So you have to be able to understand the difference between rational, irrational, real, and imaginary. That is huge. If you don't understand what we're talking about, then you're not going to be able to answer the questions because they're going to be asked differently. So let's make sure we understand the difference. Rational and irrational are real. So if the question says find all real zeros, they want both of these. But it might say just give me the rational zeros. The rational zeros are the ones, the whole numbers, the integers, the fractions, the repeating decimals, the terminating decimals, those are all rational numbers. But irrational are the ones like square root of 3, square root of 2, square root of 10. If the number does not repeat or does not end, it's considered an irrational. Imaginary are the ones that have a negative under the radical. Okay, so read the question and make sure you understand the difference between rational and irrational. Now, when you're solving these polynomial equations, there's different things you're going to do to break them down. One thing you're going to use is simply factoring. You're going to use the quadratic formula. You're going to complete the square. You're going to take the square root of both sides. You may even want to use a graphing calculator at times, but this is what we're going to concentrate on today. The rational zero test. Sometimes it's referred to as the RZT, rational zero test. And we use synthetic division in combination with rational zero test in order to find all the zeros, whether they be real or imaginary. So the first thing you're going to do is you're going to make sure that your polynomial is in standard form. And you want to look for any missing terms, anything that's missing because you want to put a zero. You need to be able to figure out what the constant in the leading coefficient is. The constant term is the number that does not have a variable. That's important, and you need your leading coefficient. That's the number that's in front of the biggest power term. Now, we're going to list all the combinations of fractions by doing P over Q. What is P? P are all of the factors of the constant. So you're going to take factors of the constant over factors of the leading coefficient. That's your Q value. And you're going to come up with a list of possible factors. And then what you're going to do is, one at a time, use synthetic division and see where you get a zero. When you get a zero, you're going to start breaking it up into factors and finding all the zeros. At some point, you're going to want to use either the quadratic formula or take the square root of both sides or simply factor it to find the remaining zeros. So let's start with some examples. See if you remember doing this from last year. Here's example 1. This is a polynomial, x cubed plus 5x squared plus 7x plus 3. Your P is your constant. This is the constant term. So P is 3. Your Q value is your leading coefficient, which is 1. So this is the possible zeros. You're going to take factors of P, which are plus or minus 1 and plus or minus 3, and divide it over factors of Q, which are plus or minus 1. Now, this is a shorthand list of all of the possible zeros. If you were to break it up, you would get -3, -1, 1, and 3, in order from least to greatest. Okay?
How'd you get positive, like plus or minus 1, plus or minus 3? Like how'd you
Because what numbers multiply, you want to look at factors of 3. 1 times 3 is 3. What numbers go into 3? 1 and 3. What numbers go into 1? 1.
Alright.
Okay? So like if the number was 6, what numbers multiply to give you 6?
2, 3, 6,
1,
and 1.
2, 3, and 6. These would be factors. And then you would put plus or minus with each one of them. Okay? So that's how you find your possible factors. Now what you're going to do is, one at a time, you're going to take these possible zeros and test them with synthetic division. Now I would suggest you start right in the middle. These two numbers. Always start with 1 and work your way out that way. So let's try the number 1. So you're gonna put 1 outside, we're doing synthetic division. How do you do synthetic division? You're gonna put all of your coefficients, so 1, 5, 7, and 3. So let's try that. Does this one work? Does 1 work? It does not, right? You want to find a 0 here. So 1 doesn't work. Let's try -1.
It's usually.
So bring down the 1. -1 times 1 is -1. Add, multiply, add, multiply. Bingo.
I feel like last year there was a way you told us, it was like to kind of guess which ones you're going to use. Or
Yeah,
what
I'm
ones.
going to show you a trick in a minute.
Okay.
All right, so this is a 0. So how do we write this in factored form? If -1 is a 0, you would write x plus 1. It's the opposite. What's remaining here is a polynomial 1 degree less than this. So it's 1x squared plus 4x plus 3. Now, we're finding all of the factors, or all of the zeros, I'm sorry. So can you now, this is an x squared problem, can you pull out of your bag of tricks a way to simplify or factor that x squared plus 4x plus 3? What way, Jasmine?
X plus 3 times x plus 1.
So, x plus 3 times x plus 1 factors into that. So now what, this is in factored form, can you write it any better? X plus 1 squared and x plus 3. Now I'm going to bring up something that you probably remember, the multiplicity of each 0. So what is, this 0 is -1, but the multiplicity is 2. Do you remember what it does at that?
It goes through.
It touches and
Yeah.
touches and bounces. It does not cross through this one. But this one it's gonna cross through.
How do you know if it's, like, how do you know it's multiple? Whatever you said that.
It's, last year we talked about the multiplicity of a 0. If the multiplicity is even, this 0 occurred 2 times, even, it's gonna touch and bounce off of it.
Right.
And if it's an odd multiplicity, this only is once, it's gonna cross through it. Now, let's categorize these 2 zeros. They are rational and real. These are rational and real. So we're gonna do another one. Example 2. Can you tell me what the p-value is? What's the q-value?
1.
What are all possible zeros?
-3.
Plus or minus 1, plus or minus 3, over plus or minus 1. So again, my zeros are -3, -1, 1, and 3. So where do you want to start?
-1.
Let's try -1. Okay. Let's try -1. Does this work? Nope. Want to try 1?
Sure.
Bring down the 1, multiply, add, multiply, add, multiply, bingo. We got our first 0. It's 1. Now what do you have left here? So x minus 1 is one of your factors. And you have x squared minus 3. So how would we finish solving this one?
Wait, so why do you use x squared minus 3?
The numbers under that, yeah.
This is what's left.
Oh, okay.
X squared minus 3.
Okay.
So now we can take the square root of both sides to finish this. How would we finish this one?
And 3, so it just equals plus or minus the square root.
So now, the question, let's go back and read the question. It says, find all rational zeros. The answer to that is 1. 1 is a rational zero. And then it says, find all real zeros. So for A, if you had that question, the answer would be 1. For B, find the real zeros, it would be 1 and plus and minus root 3. If you put plus or minus root 3 for answer A, it is incorrect. You are not answering the question. That's like me asking you, what's your favorite color? And you say, I love pizza.
It's not even.
You're not answering my question. You're not giving me the correct response. Find all the rational zeros is just the number 1. All the real is 1 and plus or minus root 3. Okay? Now on the next example, you're gonna see something funny. Does anyone know what the p-value is right now? Nope.
1.
P is not gonna ever be 0. It's gonna be -6, but how do you get, I don't see a -6 by itself.
So take out 3x.
You're gonna have, you have 3 x's here that you can factor out.
So if you don't see a constant, you take
Right.
whatever x's is on the last term.
Mhm. You wanna factor these x's out. Is that good? So I pulled out 3, so right now I have 3 zeros. I have 0, 0, and 0. So this is one of my rational zeros. One of my real zeros is 0. Now what are you gonna do with this piece? There's 3 more zeros hidden in here.
Okay, so you got your coefficient.
What's my p-value?
Oh, okay.
6.
Negative.
Don't worry about the negative. And my q value is 2.
Okay.
So tell me what are factors of 6. What numbers go into 6? 1 does,
Same ones you can-
2, 3, and 6. And what about 2? 1 and 2. So if we looked at this list, can you list them all for me? You have -6, you have -3, you have -2, you have -1, you have 1, you have 3, 2, you have 3, you have 6, and then you have some fractions. You have 1/2, you have 3 halves. Okay? So, when this list gets really extensive, I have a trick, and Nick, I think, was alluding to this little trick that I was gonna show you. Okay, these are called the C-values. If you flip to the next page, it's explained to you here. If the number you pick is a positive number, and when you're doing synthetic division and you get all positive numbers down at the bottom, that number is called an upper bound. That means, hey, that's too big. Go the other direction. You're too big. Your graph's shooting up. This is too big. If the number you're testing is positive and you end up with all positives here, don't go bigger, go smaller. On the other hand, if you test a negative number and you end up with this checkerboard, plus, minus, or it could be minus, plus, but they're alternating signs, that number is a lower bound. It's too small. Don't do the smaller numbers. Go bigger. So, look at this list. Let's say I tested the number 1 and I get all positive numbers. 1 would be an upper bound. What is that telling me not to do? Don't do 2, 3, or 6. You're wasting your time. Go the other direction. On the other hand, let's say I tested -2 and I got my checkerboard, plus, minus, at the bottom. That number's too small. Don't waste your time and test these ones. Does that make sense? So, did I give you anything wonderful? It's something. Instead of having to test all of these, it's something to use to help you. Now, sometimes a 0 can occur more than once. So you may have to test some numbers twice. So let's start with, anyone want to start with a particular number here? Usually the best thing to do is start with in the middle. Because if you're gonna find an upper or lower bound, you can cross those out. Don't start with 6, because that's not gonna help you. Start in the middle. I would start with 1. Now you're gonna see that 1, now this one you need, now remember, you're only testing this, you're breaking this piece up. This is already broken up. So you have a 2, a -3, a -7, and a -6. So when I bring down the 2, and add, and multiply, and add, this does not work. I get -14. Now, it's not an upper bound, so I'm gonna try the number 2. Bring down the 2, multiply, 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 and nope, that's not gonna work. Try 3. This is what happens. Unfortunately, I didn't see any patterns, so I'm gonna keep going. 2, 6, 3, 9, 2, oh, here we go. We found it. That's our first one. So, what do we have so far? We have x cubed, and then we have x minus 3, and what's left? 2x squared plus 3x plus 2. Once you get to an x squared polynomial, that's when you're going to pull in your quadratic equation, complete the square. You don't want to complete the square on that one. That's yuck. And this one's not factorable. So I've got an indication that this is probably going to be an irrational or imaginary. So what we're going to do is try to break this trinomial up into its factors. Now, what am I writing here? Quadratic formula. The quadratic formula works on every quadratic problem. So that's your safe house right there. You can go with that all the time. So let's try -3 plus or minus 9 minus 4 times 2 times 2. But something is screaming out here at me. Does anyone know what's screaming out? I'm not going to even finish the problem. Does anyone see what I see? This is going to be negative. What, do you guys remember what this is called? 9 minus that?
The discriminant.
Very good. Bingo. Tara, did you say that?
Kara.
Kara. Kara, Tara, Kara. I'm sorry. Okay, so you're going to find the discriminant, and it's negative. So what are these two solutions? They're imaginary. So you don't have to finish this, because the question said,
It wants all
find
real,
all
irrational.
rational zeros.
Rational
The only
zeros.
two that we found are 0 and 3. These are imaginary. Next. So I showed you the upper bound. Let's try this one. Give me what P is. What's P?
2.
And what's this? 1. Now check this out. I kind of already told you what happens in situations like this. We have to find up to 5 zeros. But look how many possible zeros we have. We only have -2, -1, 1, and 2. I only have 4 zeros. So what do you think is going to happen? What's your guess? Maybe one of these zeros might occur more than once. So what am I going to put here? 1, -2, 2, 0. Why did I put a 0 there? Because it's x squared. So bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, That's what we want, a 0 there. So we got one of them. We're chiseling away at this polynomial here. So far we have x minus 1. Don't forget, even though this is a 0, how do you express it as a polynomial? It's the opposite of that number. So what remains here is 1x to the 4th power minus 1x to the 3rd plus 1x squared plus 1x minus 2. What do you think you're going to do with this now? Keep breaking it up. I would try 1 again. So now we're going to use 1, negative 1, 1, 1, and negative 2. Let's see. Bring down the 1. 1 times 1 is 1. Add. 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 Oh, wow. This is 2. It worked again. So guess what we have? We have x minus 1 quantity squared. And what's this? It's going to be 1x cubed plus 0x squared plus 1x plus 2.
Can you move your paper really fast?
Now, we're going to, can I move it? Which
Yeah,
way?
can you move to
This way?
or off so I can see the whole thing.
So now, if we try 1 again, it's not going to work. Let's try something else. Let's try negative 1. So we have 1, 0, 1, and 2. Bring down the 1. Multiply, add, multiply, add, multiply, and add. We got another 0. So far we have x minus 1 quantity squared times x plus 1 times, what's left here? How do you read this last part? X squared minus 1x plus 2. So x squared minus x plus 2. Now, there's 3 questions that they're asking you here. Find all rational zeros, find all real zeros, and factor it completely. We've been factoring it. And I believe this is factored completely because this, I can't factor. Let's try it. We can use the quadratic formula. Let's do it. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. But when I do that, what am I finding? So 1 minus 4 times 1 times 2. What kind of discriminant am I getting here? I'm getting a negative. So this is showing me that these are imaginary. So now let's answer A, B, and C. The question for A says, find all rational zeros. 1 and negative 1 are my rational zeros. B says find all real zeros. Well, guess what? Not only are these rational, but they are real. And C says factor it completely. These 2 answers were imaginary. They're not rational, they're not real. So the factored completely answer is this. We can't factor this any more than what we did. That's factored completely. Okay, your homework is, I want you to do, there's 8 problems here. You're gonna do the RZT test along with synthetic division and test these. Now there's 2 questions I want to give you a hint on. Number 7. This says 1/12 x cubed minus 1/12 x squared minus 2/3 x plus 1. The constant is not going to be 1. We want to get rid of these. We want all of our coefficients to be integers. Right now they're not integers. So what could we multiply everything by? 12. If you multiplied everything by 12, can you tell me what you get? X cubed,
Add x squared.
uh-huh,
Minus 6, 8.
and then plus. So this is what you're gonna start with. So your p-value is 12, and your q-value is 1. Same with number 11. You do not want decimals for coefficients. How can I get rid of all the decimals here? What would I multiply this whole thing by?
10.
10, or move the decimal one place over. So it'd be x cubed minus 19x plus 30. So your p-value's 30 and your q-value's 1. Anyone have any questions? Okay, that's your homework.